The last thing that we're going to talk about today is techniques that you can use to switch the values of variables. Every so often you'll have a value stored in one variable and a value stored in a different variable, and you'll just need to switch them. This is a technique that we'll run into eventually. The most straightforward way and the most universally applicable way to do this is by creating what we call a swap variable, which is just a temporary variable that kind of does a placeholder. And here's what this looks like. So we create our first variable, our second variable, and then we create a temp, which we set equal to, in this case, our first variable, but it doesn't particularly matter how you do this. So when we look at this, we have x is 12, our temp is 12, and y is 93. Then, so our x value is stored in temp. That frees up our x variable to store whatever the y value is, right? So now x is 93, our temp is 12, and y is 93. And then finally, we take our y value and we put our stored temp value. Remember, the temp value comes from x. So our value from x goes from x to the temp to y. And our value from y goes from y to x. And so this is one way that you can swap. And this works with every variable type. If you have reference variables that point to objects, we'll talk about those later, or if you have numeric variables or primitives, it works with every single variable type. And by and large, this technique is a thing that you can almost copy and paste anytime you need to swap one or more variables. And if you need to swap lots of variables, you just create an additional temp variable, and now you have a slightly larger wheel that you rotate them through. Okay. The other way that we can do this, and this is sort of this is a trickier way, and this is a way that is this is a way that's more difficult. It's more difficult to remember, and it isn't a thing that's actually ever going to be particularly useful to you. Is to switch to numeric values without a swap variable. I'm going to suggest that you don't use this technique. However, I want you to know that it exists, mostly in sort of like a way to expand your own thinking. For right now, though, I consider the temporary swap values as the easiest and most transparent ways to switch things. The more difficult technique, which is only particularly useful if you're using like embedded microchips and memory is at an absolute premium, is to do something like this. Okay, so we've got x is 12, y is 93. We assign to x the sum of x and y. So now x is 105 and y is 93. Then we assign to y the difference between x and y. Okay, so it'll be 105 minus 93, which gives us 12. And then we assign to x the difference between its old value, 105, and our new y value. And so when we do that, we end up with swapped variables. This only works with numbers, and it only works, it doesn't work particularly well if you're dealing with floating point numbers. This floating point math is sometimes weird, and we'll talk about that in a few weeks. Which is to say that this only really works well with integers that you might need to swap. But to show you real fast what this looks like, I created a quick .java file. Okay, and all this is up in the GitHub. So we're going to collect two numbers. We'll print out those numbers before we swap. We're just calling them A and B. And so we'll print out the value of A, and then the value of B. And we'll swap those numbers by creating a temporary variable. And you might be thinking right now, hey, wait a second, if we create a variable, doesn't that use up more memory? And the answer is, yes, of course, but computers right now are so fast and so powerful that an extra integer doesn't matter even a tiny bit. Like that is a fraction of a fraction of a fraction of a fraction of 1% of your computer's available memory, assuming that you have a computer that was built more recently than 10 years ago. Which is to say, it's not a thing that you'll ever have to worry about. Not until you start creating billions or even like high millions of integers will you start to see a performance hit, and even then probably not. So switch in this block using a really fast temp variable swap, just like what we saw before. And this is one that you can use for every single time you might need to swap two variables or the values stored in two variables. We'll output the results here on line 23. And then right below that, we'll switch those values back using the no swap using like the no temp variable method, using the addition. This is a little bit more tricky math. It's a thing that you might see in like a programming interview. It's a trick, and it's not a trick that you'll probably find ever useful unless you're doing embedded circuits. We'll switch that back. And that'll just be, you just might have to spend a little bit of time with it, like get out a sheet of pen and paper and kind of work your way through this. We'll quit. And then when we run this, we'll ask us for two numbers, right? So let's say 48 and 93. Those are reasonably sized numbers. This is before swapping. A is 48, B is 93. After swapping, using a temp variable, A is 93 and B is 48. And then we swap them back without the temp variable. A is 48, B is 93. And again, this is a thing where I think my best suggestion would just be to spend some time with all of this. In particular, like grab a sheet of paper and just kind of work your way through all of this by hand. And that'll be a good way to kind of figure out what's going on. To wrap up, the thing that we talked about today is using, in terms of like from most useful to least useful, we talked about the compound assignment and the unary operators. Those are the things from today that will actually be really useful to slightly speed up our programming. Though, and in particular with the unary operators, we have to make sure that we're being really careful that we maintain readable code. And we also talked about swapping the values of variables, and that's a thing that you'll need for at least one or two of the assignments that we deal with this semester, but not a thing that you'll probably have to worry about too often. The next thing that we'll talk about in this course is loops. That'll be the next thing that we talk about, that repetition structure, which is to say that you may wish to consider reading chapters 3 and 4. But I'll see you in the future.